Hello, everybody. Hello, Shubham. Nice to see you.
Yeah, hi everyone.
So maybe we should get started. I think more folks might join eventually, but we can perhaps get started. What do you think, Alan?
Yeah, that sounds good. Oh, actually, we got Morris.
Oh, nice.
Yeah, cool.
Hello, Morris.
Look.
Let's maybe give it a minute then.
Well, in the meantime, I'm gonna share some links to the agenda as well as the meeting notes. So if you would like, feel free to list your attendance as well as any other topics you would like to discuss.
Agenda. Meeting notes. Nice. All right, so perhaps I can introduce Shubham a little bit. Shubham, first of all, thank you for joining today and for presenting today. Shubham is actually, correct me if I'm wrong, Shubham, so you're an engineer at Chaos Native, and you have been looking in, I mean, you can definitely, I'm hoping you will explain what Chaos is. For many of us, it's a new concept. And you've been looking into doing chaos experiments alongside SLO validation, and you've explored Iter8 in that context, and that is what you're presenting today. Is that correct?
Yes.
Okay.
So,
all right. Yeah.
Yeah. So can I start with the demo?
Yeah, I think it's all yours.
Yeah. Okay. Yeah. Thanks. So I'm sharing my screen. I hope my screen is visible.
Oh,
so
yeah.
for the
So
today, our topic is we will use Litmus for the chaos engineering. I mean, for the injection of the pod delete chaos. So we have a hello world pod, which is just printing the hello world, and it is also printing the host name. So we will use hello world pod as a hello world deployment as a target application. We are injecting the chaos using Litmus, and at the same time we are validating our SLOs with the Iter8. So in Litmus, I will just start with the chaos engineering, where how we will use it in by the Litmus or something. So if you see, this is our hub where we have a different experiment. So we are performing different experiment, and we are checking the application's resilience based on those experiments. So it can be pod delete, CPU hog, memory hog, or like network loss, network latency, network packet duplication or corruption. And similarly for the node level, like node memory hog, node CPU hog, then disk fill, and node drain, node taint, and all those. So most of them are like pod and nodes level are from the Kubernetes, and we also have some non-Kubernetes experiments. So for this demo, we are using pod delete experiment. So we have a deployment, and we will delete the replica of it. And here I will go through. I will just go through the steps. So the setup is already ready in my cluster. So I will just go through. So I will explain one by one. So we can see these are the prerequisite for the Iter8. So we need to install the Iter8, and then we need to install the Iter8 command. So we can install it. Then after that, this is the Hello World application where it contains two versions. One is baseline 1.0 and another one is candidate 2.0. So we will install these application, and like we are performing the chaos on candidate version. So, and we are also validating the SLOs for this. So we will go through what are the metrics we are checking, but we are validating the SLO for the candidate version. And if the candidate passed the our test, like SLO validation, so then we will upgrade the version. Otherwise, it will be same as baseline. So this application is running in two different versions. One is name as Hello, one is Hello-candidate. And then another one is, then after that, we can install the Iter8 experiment, which is validating. Let me open that. So this is the Iter8 experiment which we are going to use. So it is waiting for the like candidate to up, and it is just waiting for the candidate service and deployment to be up until it will wait. Then it start collecting the metrics from this URL, which is the URL of the Hello candidate service. And here we are checking three metrics. So these are the three objectives. So we are checking the mean latency. Then we are also checking the error rate, and also the 95 percentile latency. So all these criteria should be matched to pass this. So we will finally we will get a table where like inside the described output we will see what the criteria is for like passed or failed based on this. And here we have a one iteration. So in each iteration we can see here the QPS is 8. So for every second we are sending 8 query per second, and for the 90 second. So for the 90 second we will send 8 query per second as part of this, and at the same time we are validating these SLOs. And I will also show the like my application. So my application is this. If you see this, so here are the two versions. So this is the Hello World, which is a baseline. Here the version is 1.0, and the another application is another version is 2.0. The name of the deployment is Hello-candidate. So we can also see the corresponding pod here. So this is the Hello candidate, and this is the baseline one. And these are the like control pin component of the Argo workflow. And this is okay. Let me use the default only. Okay. I am using default namespace as my target namespace. So here you can see the our like litmus operator is running, which is the control plane for the litmus experiments, and these are our applications. And here we are using pod delete experiment, so we can verify the experiment installation, which I pulled from the chaos chart, chaos hub. We see the pod delete experiment is already there, so we can start the chaos. So before going to that, I can show the service as well. I mean, so these are our service. We can check what it is contained, and I using the load balancer type here, so we can just open it. So we can see this is just printing the hello world, and which is version 1.0 and host name is there. So similarly, we can do this. This is version 2 and host name is this. So like we will go through 2 iterations. So in the first run, we are using the only one replica of the candidate deployment. So because one replica is there and we are deleting it. So let me open our engine, so which is doing the chaos. So you see we have provided the application namespace as default namespace, and this is the label for the candidate deployment. And this is the kind deployment. So it will delete the candidate deployment for the 200 seconds, and for each iteration there will be a 8-second delay in each iteration. And we are using pod delete experiment. So so because we have only one replica and we are deleting that replica, then the SLO will there is a high chance that SLO will fail because the replica is not ready. So in those cases, like for the one replica, our SLO validation will fail. So of course we will not go for the candidate promotion. Then in case of a 2 replicas, we will see, because like we are deleting only one replica. So at the same time the one replica is ready. So our SLO should be passed. This is our expectation. So we can start running the experiment. So I'm running both. I can create both at same time here. So this experiment is the Iter8 experiment. Then engine is for the litmus engine, which is doing the pod delete. So I'm just doing that. And also we can watch for the describe output of this, so which will explain about the iteration and all the metrics. So let's see, the iteration started. Here also we will see the pod delete pod is started, which will start deleting the candidate pod. So we see it is 63 minutes ago. Now we see 9 seconds ago. So it's deleted for the first iteration. So for the each iteration, it will start deleting it. So as we have for the 90 seconds, so it will take 90 seconds. Like after 90 seconds, we will see. So here also, because one replica is there, we can check this. Because it will be live, because at some moment, I mean, for the sometime it will be live and sometime it will be not active. We can, because we are deleting it. So, as we are not using any readiness or liveness probe inside this deployment, so sometimes it is start immediately. It is not taking some time. If we have some readiness probe or initial delay seconds, then of course this application may take some time. Then in those cases, we can see this is not active or live on this case, but because it is started in few milliseconds or like within seconds, so that's why we see it is always active. But we will see our like QPS SLO validation, it may detect it even if it is starting in few seconds. So we can wait for the 90 seconds.
So, Shubham, while we are waiting, I had a question. You said that only one of the deployments replicas will be deleted by pod delete. Did you specify it somewhere or no?
Yeah. By default, it will delete only one. I mean, there is a option env, which is pod affected percentage. So if we will add the like affected percentage inside the as a percentage, for example, 100%, and there is 2 replicas, so it will delete all the replicas. But right now, because we have not set any percentage, so it will delete only one replica in those cases. And right now, because I only have one replica, so that's the only case for this. I think this is completed, so we can see the output. Okay, so we see the 95 percentile is failed. So which is, I mean, we see that for the new version, it is false. So it is failed because we have only one replica and we are deleting that replica. So it is not able to get, like there is a latency for 95 percentile. So which is less than 1000. So it is false. I mean, sorry, which is greater than 1000. So that's why it is failed. Yeah, we see it is 1354. So that's why it is failed. So we see the SLO is not working for our like one replica. We can also see the litmus chaos result, which will also explain about like chaos experiments. So here we see the experiment is passed because the deployment or the replica set is able to start the replica every time whenever we delete it. That's why it is passed. So because in the end of the experiment, the candidate pod is up and running. So that's why it is passed. So we can also see the target details here, which is the name of the deployment, then kind of the deployment here, because there is no specific injection or reversion. For example, in CPU or memory, we inject the CPU or stress, then after some time we revert it. So there the chaos status is different. It is injected and reverted, but in the normal case, because it is managed by deployment, so the deployment is targeted because the pod will restart it by the deployment itself. And we see the verdict is pass. So again, like I will scale the replica count. So I can scale the replica count to 2. I mean, do anyone have any question? I will go for the second run. I think it is taking some time. Okay, so it is scaled. We see now 2 replica of the candidate deployment. I can delete the experiments. Okay, so we can again start the experiment for the 2 replicas this time. This is taking some time. Okay, it is created. Okay, it is created. So again, it will run for the 90 seconds. And this time, because we have not set the pod affected percentage as 100, so it will delete only one replica of the hello candidate deployment. So we see this time this deleted. It will delete a random replica because we have not specified the name. So sometime it will delete this, or maybe sometime it will delete this as well. Yeah. So delete this replica this time, and here we will wait again. So we can also verify this. We can see this is changing every time, like after deletion this host name, because every time we are deleting the pod, so it is changing. So we can wait for 90 seconds. And we can also check the logs as well for this pod delete. So what is it is doing internally. So we see like first is check the status of all the deployment. So both are running and container are ready. Then it start killing. So it's just printing the number of targets. So in our case, it is one only. Then it is killing it. Then it is waiting for 8 seconds in each iteration. Then same repeat for every time. And each iteration is also verifying that the application should be come in running straight again before going for the next attempt. If you want to check the uses of the pod delete experiment, so we can see the uses here as well. So where we can use the pod delete experiments in our cluster. So there are different use cases. So I can share this on chat as well. It is completed. I can describe it and check the SLOs.
CTL seems to be taking a bit of time after you kill it, kill the watch, and then do it again.
It is not taking time. I mean, it is maybe my internet issue or something, because you see, sometimes I'm not able to watch this as well. So it is, I think, some internet issue or something. Okay, so this time we see all the validations are all the versions. It is passed for all. You can see now it is 720, which is less than 1000. So it is passed, because this time we have 2 replicas, and at one moment one replica is up and live, so it is able to get those metrics. So there is no latency. I mean, there is latency, but it is not greater than 1000.
Yeah, actually your latency is 1 millisecond. It's all the way down below.
Yes. So we can, at the last part, if we see the experiment, our SLO is passed. I mean, all the SLO which is defined inside the Iter8 experiment, which is passed, then we can upgrade the version. We can check this. So we can upgrade the version using Helm as well. So right now, for the demo purpose, I have not used Helm. I just install it in my, so that I can show all the manifest directly here, all the value which is provided by me. So I use this example, but yeah, from this experiment, from this first experiment from here, you can see all the steps which can use Helm. For the Litmus integration as well, we will update the docs here as well, so that for the Litmus also we can directly use the same Helm and we can install it as well together. So we'll work on it. Right now we see it is work, and also we can see the describe output. It is again passed because one replica is active for him this time as well, so it is passed. Okay, sorry, I have not refreshed that time. That's completed. So we see this is passed now, and the pass count is also increased by 1 and chaos state is same. So this is all about my demo. I mean, I am open for the questions. I can share this link as well, which we used from the Iter8. I shared the link in the chat.
So this is really excellent, Shubham. Thank you so much for the demo. It's very interesting. I have a couple of questions. I mean, Morris and I, we were chatting yesterday, and this question came up. Question is, do your users actually use chaos engineering in production clusters? I mean, it kind of looks very scary to just go about deleting pods, and they are serving user traffic. So do you think that's how users use it, or do they use it in staging environments?
Yeah, I mean, most of the users, use them in staging only. But I think there are some user maybe which is using in the production. I'm not sure about their use case exactly, but yeah, but there are less number of people who is using production. More of it they are using in staging environment on.
Even in the production cluster, maybe they have a different namespace where they are essentially staging these experiments. Maybe that's what is going on.
Yes. Yeah, in the production it is, yeah, of course it is risky. So yeah, mainly they are using in staging only. Then if it is good, and then they will use, they will like upgrade it to the production, like application other thing.
So if that is the case, then maybe the scenario could be that you don't even have a stable and candidate. We just have a candidate. Candidate appeared in staging, and we are doing an experiment with it in staging. Maybe we can even simplify the whole setup. We don't even need a... Anyway, your experiment didn't require the stable version, right? Nothing in your demo required the stable version.
Yes, it can be any application.
Right. The other question that I had was, you know, just in terms of taking this forward, there are so many options here, right? So we can make the entire scenario Helm based, or everything, all the manifest Helm based, or we can just make the experiments Helm based, so that, you know, I think that's what you showed today. You have a deployment that is deployed, services that are deployed, but you don't assume that they were created using Helm. But you still have a way of, you know, defining these experiments using Helm, so that the experiments can be templated using Helm. Is that a better scenario than, you know, targeting entire application using Helm? Because then we are kind of limiting ourselves to Helm users. Here, I think what you showed is you use Helm to deploy experiments. You don't care how the application itself is deployed. Is that correct?
Yes, but yeah, to run this experiment, we need the application beforehand. Like if we are using Helm, then of course, because we are installing both at the same time, so we know the application label as well. But when we are installing the engine, for example, when I'm creating the engine, then that time I need the application details, because it is bind the experiment with the application. So I need the application detail. So if application is already installed, then of course it is good. So we can directly get the application details, its namespace, its label, then we can directly provide inside the chaos engine and we can create it.
Right. So I'm guessing we can create the application ahead of time. This way we don't tell the user how they created their application. They can use Helm to create the application, or they don't need to use Helm. Whatever way they normally use to create the application, you create. And we just pass the application labels, any application specific information, to the experiments as Helm values. That might work, right? Then we don't have a dependence on Helm for your application. We are just introducing the Helm dependency for the experiments.
Yes. Yeah, we can, like when we installing the engine, we can directly pass the application details, which is maybe already installed, then we can directly use it.
Okay. So that's the other question I had. I'm a little bit confused. So when you say engine, that is not the litmus control plane component, right? That is actually, engine is what you refer to as a single experiment. It's a single chaos experiment, right?
Yeah, it is a CR. So if we have a 3 CR, like CRD, then we are creating the corresponding CR. So we have 3 CRDs. So one is chaos experiment, so which is a static information about the experiment only. So which can be which we can pull from chaos hub as well. So there is a chart, we can actually pull it, contain all the experiment information. Then we have a chaos engine, which bind the experiment with the application. So which bind both of them. Or if we need anything like config web secret detail, we can directly override it. And if we want to override anything which is already provided inside the experiment, for example, duration. So the default duration for the pod delete experiment is 60 seconds. So it will run for 60 seconds only. But if we want to change the duration, then we can override the duration inside the chaos engine.
Got it.
So yeah, we can override any value. So the user will interact with engine only. The experiment is a static thing. You can directly pull from it. So it is already in your cluster. Then you can directly bind the experiment with the application and you can run it. And if you want to override it, anything, then you can also override it. Then final one is the result. So result is more of the like user will not create it. It will create by Litmus itself. So where the user can check all the details. So if experiment is pass or fail, if it is fail, in which step it is failed, what are the application which it targeted, all the events, like what are the cumulative values which is already run. For example, number of past experiment which is run, failed, stopped. All those information we will get in the result. So it is the summary kind of thing. The similarly we will get from Iter8 described. Similar. This is also a kind of summary which we have.
Right. Yeah, you showed us the results, so that makes sense. Now, what the follow-up question I have is the chaos experiment. You said is the static resource, and it can be overridden by the chaos engine. How does that mechanics actually work? So is this like Helm based values overriding, or is it just plain Kubernetes resource and there's some override internally? You have chaos implements.
Internally we are managing it. Like internally, okay. Like we have a control, like operator, which is a controller which create a, like for example, we have a start handler, right? So similar way we have a runner which is basically take all the information from the experiment plus engine. Then it will, like based on it will create the actually experiment job, which is the pod delete hyphen something. So which is actually injecting the chaos.
Got it.
So we have an intermediator called chaos runner, which is performing all those things. Like if there is some volume or if there is some security context as well, anything which is needed for the experiment. So it is handling all.
Got it. Any other questions for Shubham? Anybody? All right, so I think this is fantastic. What do you think the next steps are? I'm wondering if we can perhaps we can document it on Iter8.tools as well as the Chaos Native website, the tutorials, and then maybe we can discuss a blog article. I mean, there are so many options. We can also go to, I think we should give a talk in your community meeting also. So that may be another step. And we should also approach, there's so much Helm is involved. I think we can also go to CNCF tags, community. There's they used to call it SIG, now they call it tag. So CNCF tag apps. And maybe give a talk there also, so we can perhaps plan for a little bit more wider dissemination of this demo of this feature.
Yes. Yeah, we can start with the tutorial. So in the tutorial, we will use Helm, or we will use like split the Helm of Iter8 then experiments, or what?
My feeling is we should split the Helm. We should keep Helm for both the experiments. The chaos engine, and for Iter8, they both need some templating, and they both need some, passing some values in. And my feeling is we should keep Helm for the two of them, but we should not introduce Helm dependency for the application. That's my feeling. Yeah. What you showed today is, I think, the scenario we want, because we don't want to restrict this feature to only those users who are using Helm to release their applications.
Yes, right. So I think if I will split the Litmus into 3 parts. So first part is the Litmus installation itself. So which is of course not needed Helm. We can directly install it via one command. Yeah. Then second part is the chaos experiment, which is also a static thing. We can directly pull it from hub. So it is also able to install. We can directly use it one command, then we can install it, right? One liner for this as well. The third part is the chaos engine, which is basically a dynamic resource. So where maybe the user need to provide an input. So for the chaos engine, either we can provide a collapsible YAML, basically a sample YAML where user can copy it and use accordingly. I mean, or we can use a Helm as well. For the engine, I think we can go for any of the approach. But for the other two part, I think it is okay if we will not use them, because they are static, and I mean there is no user input required. So the Helm, I mean there is no templating and all. So.
Right.
For the engine, we can think of either the Helm, or we can directly provide a sample manifest, then they can add it in or something.
Yeah, yeah, that makes sense to me. What you're describing makes sense to me. At least this way we minimize the Helm dependency for the experiment components and not for the application.
Correct. For the current use case, I think we just need to override, I think, duration, interval, and application details. These three things we need to override, right?
Right, exactly.
So yeah, those only the three things are there. So I mean, if we will not use Helm also, then also it is okay.
Yeah.
So we'll provide a proper documentation, and we will highlight the items which we need to override. So
exactly.
Yeah.
That works also. That's how most of our experiments don't have any Helm dependency. It's just, this is how the experiment, we just provide the raw experiment. So that also works.
Okay. Yeah, so we'll start on the tutorial side as okay.
Very good. We can do either way. If you want to open a PR, I would love to contribute to that PR. I mean,
yeah, I can open a draft PR or WIP PR, then we can collaborate and update it.
Yeah, draft PR, and we can collaborate on the draft PR. Or if you want us to start it, if you want me to start it, I can do that also. It's flexible, so everything is possible. Okay, let's start there. And I think we definitely want a new stack blog article out of this. We are, all of us in the call or from the Iter8 side in this call are from IBM, and IBM actually has a push towards publishing articles. We now have a partnership with NewStack, and there's a very, very big readership for NewStack blogs.
Yes. We also, I think, we also published on NewStack recently for the 2.0, I think.
Right. So we can reach quite a big audience through this NewStack channel. So let's take advantage of it. We can once we have the tutorial, we can start discussing the blog article.
You can share the directory where I need to push all those things. I mean, because earlier it was Helm, so I was aware about, we had to pull Helm and all. So right now, because it is just like main of the document kind of thing, it will be a readme.md file.
Right.
Or something.
Right. I can point you to that directory. Yes.
Okay. I will push.
Yep.
Or where can I add in navigation also? You can also point.
Yeah, absolutely. I saw that your chaos documentation also uses MKDocs, so it's very similar. It's exactly.
Yeah, I was working on that only in the last release. So we are using MKDocs also.
Very easy.
Yeah, it is very good also. Yeah. It is better than Dockersaurus. So earlier we were using Dockersaurus, so it had few limitations. So it is very cleaner than the Dockersaurus.
Yeah.
Okay.
All right. Sounds good. So thank you, Shubham. I know it's late for you, so you're welcome to hang around. But if you want to,
okay.
Sleep, so that's also okay. Yeah.
Yeah. One question. Do we have any recording for this, or like? Okay, this is the recording meeting or what?
Yeah, this meeting is recorded, and I will be uploading it to YouTube later.
Okay. Because I did not see any recording thing. Okay, maybe it is.
Mm-hmm. Okay. Yeah, it's recorded. Yeah.
Okay. Then okay. Yeah, I will see in the recording as well. Like. Okay.
All right. So what's next on the agenda? Do we have another item on the agenda? I don't think so.
I think that's it.
Good. So we have a few other topics. There's a whole push towards, stable APIs, and we are moving towards V2 Beta 1. So we will have more to talk about it, hopefully next time. But I think we are good. This is very nice, productive.
Yeah, next time I can also talk a bit more about Linkerd.
Yeah, I think for Linkerd integration, we want exact same story that Shubham is doing today, which is we keep the Helm, but keep it for the experiment, but somehow release the application from Helm dependency so that we don't impose that for the application. Yeah,
That makes
I think it's easy to fix. So it's something. A couple of our other tutorials have the same issue. I think I kind of like what Shubham showed today. We probably should do that for
Mhm.
all our tutorials. Yeah. All right then. So we get back 20 minutes. See you all soon.
Okay, see you. Thank you.
Yep. Bye-bye.
Yeah. Bye everyone. Bye.
Bye.